Good afternoon. Now I think you can hear. I guess looks like energy is very down right now. Only few people in the room, which is good. We can have a good interactive session. All of us actually talk about energy transition. Uh, what does that mean, and how it will look like, and how we can optimize it, or how we actually accelerate it, will all actually depend on how we actually leverage the data behind it. And especially energy sector now, since last year, in 2 days, we've been hearing a lot about data, AI models, and I'm not going to talk any of those things because those are just tools as far as I'm concerned. And I'll tell you why models are good and we have to build them, but actually, how do we look at the business problem as well? We actually mine roughly petabytes of data and generate value significantly. But looking at the bigger picture of the world, that's what we want to focus on. And unlike other industries and my past experience, I've worked for internet companies, e-commerce, consumer data, many other companies before I came into the oil and gas industry. But I do have a background in quantum physics as well. I was a professor for many years before I switched to the corporate world. So when I look at this industry, it's you can't do really pure data science on data alone. You have to really look at the science and engineering that is there. Without that, you can fit things, but it will not make any sense. So why is it important? So if you look at the energy transition, it's really complex. And how complex is it? I think this picture on the right hand side really explains it. What source of energy, how we are going to consume, and what will be the maturity of that energy in terms of production and consumption would be there. All that we can actually track with data. And it will look like a very complex landscape. And every company, every organization will fall in one of those valleys basically. So if you really try to optimize for yourself what sources of energy you want to use and how do we generate that energy, it is really only way to do it is through data. There is no other way. And in fact, if you really do it correctly, then you can generate exponential value from the data. In the sense like, you know, most people in other industries will talk about what you call creating models that are accurate, trying to figure out, predict something. But in terms of our industry, I feel what we are actually looking at uh, from a small amount of data, so to say, small is could be large in terms of terabytes, but how do I generate exponential value? Because that is the key part. And value is in terms of cost or revenue, or in terms of what you call profit margins, or in terms of safety. Right? There are various methods or financial metrics that can be applied. Unlike other industries, whether it's e-commerce marketing or social media, everybody talks about building models that are production ready. For us, production ready means nothing. It has to be field ready. Because the risks associated, I think somewhere we have discussions on healthcare industry that they are regulated and they have high risk and all. Energy industry also have very high risks. So if you build a model, you just can't take it to a field and say, oh, my model was 19% correct on the test data, so let me put it on the field to monitor my big pumps. Right? So the model has to be field ready. Field ready requires a significant amount of understanding of science and engineering behind it and a significant value of human cognition. Right? It is by experience that you know how this particular area, whether it is field in Texas or in Nevada or in Middle East, how do they behave? Right? So human cognition becomes a critical component of it. And that as a result, pretty much anything that we do will have one is the data part, the second is the science part. How does that work further? Right, I can look at the data and fit a curve. I'm simplifying it. you can really simplify and put a curve to it, and you can have a really great fit and say my model is 99% correct because I can predict the curve that is there. But it can speak to completely wrong geology or a completely wrong operations, right? So, and also, as I said, just an example earlier, that what is in Texas versus Nevada versus Middle East, that context becomes very, very critical for a similar operation that is being done in all these parts of the world. So your AI models that you build has to really take into consideration those kind of things. So for let's take by an example. You know this is called a drilling performance. And now you can look at the drilling performance in your teeth as well with the dentist. They also do the similar kind of things. They can do robotic surgery for your teeth, but the size is very small. It's like few millimeters. What we are talking about thousands of meters, right? So if you're looking at the performance, this is how your engineering or scientific formulas will tell you what the performance should look like. But when you go to the real world, what you see is this performance, which is really a curve, which makes no sense unless you understand what is the depth of the process, what kind of rocks are there, or what kind of fluid have you used. All those things go into this in creating this or this chart. So if I were a simple so-called data-driven and not knowing the process behind it, I can really put some kind of a formula behind it to actually explain these peaks and say my next peak will happen here. But that is not going to be the real world, right? Because this was probably clay, this is hard rock, and there could be something completely different. But the curve will fit very well. So knowing the geology of the subsurface, as we call it, under the earth, which we cannot see, is very, very important, right? And hence, a significant amount of time that data scientists spend is trying to collaborate with the domain experts or subject matter experts. Unlike many people say, data scientist means just play with data. For me, a data scientist is a person with computers, so-called computer data scientist, and a domain expert together. Otherwise, this whole thing is here for us. But in order to do that, eventually what we have to really do is, if this moves, is understanding the data in the context that we are trying to do. Because, as I said, I just gave you an example of 3 areas. We actually start looking at data in those areas so that we can prove that the data has a value. And unlike many other examples, and I used to work for AOL for many years, you would take terabytes of data, do modeling without thinking, because you could do that. It was similar kind of data. Here we have, even for the same problem, it may be similar data but not exactly the same. In that case, you don't want to take large amounts of data in the first place. You want to really take a small set of data and then actually start scaling it up, and then understanding how do you integrate data sets from different places. And then you start trying to, since everything is a real time in most of the operations, you want to start building real time insights. And eventually, someday, you can actually build what I call the field ready solutions. It's challenging because we don't think in the fashion that how do we connect data sets in a complex process. And it requires a paradigm shift actually. One has to really go beyond simple data, and especially when it is what you call structured data, we are so used to it, right? But it requires a new kind of thinking. So here is a nice, highly organized data. Some of you might have seen this if you've heard me before. My business question is, what do you see here? A family of tigers in the natural environment. Anybody else? Sunset. Nice. All right. Lots of embedded tigers. Now, but it's a beautifully structured data, right? Coming out of a data warehouse. That's how we spend our lifetime trying to put all the data in data warehouses. or data models, right? But when we start looking at it, we only look at things that we know, right? All of us, and I've been using this slide for last 12 years now. The first thing that people will only see tigers. At least you are ahead of the game, you said tigers in a natural environment. But most of the people would only say tigers. The question was, what do you see? So we have data, but we don't actually ever look at the data in its full form. Say that again? So you see parrots now, even after I said something, right? Alright, now let's say the operational question. How many tigers? Five? Seven? Lots? No, lots. That's the count. We're an AI conference, let's go numbers. 9, 10, okay. Can I hire you as a data scientist? 8, 10, okay. Say that again. Anybody more than 10? 12, okay. 12. Anybody more than 12? You see, we we build we take data, we actually spend a lot of time putting in various data models, then put it and store it in the data warehouse, then we build dashboards, and then dashboards are built for what I want. So again, right? But dashboard is what I am thinking, that's what it is. Right? So it's the same thing like when I shoot a curve, you can nicely draw a curve which looks exactly like the data that we got. But we missed out a lot of things. And this is where I said science and engineering is required, or a new kind of data set is required. Now I call this as a highly structured data, beautiful looking. But what happens if I really took unstructured data, which has no shape, no size, and see how we start thinking about it? Now you can count. So the thing about doing correctly the data science for business is actually to look beyond what we know, is to integrate data from all other places that are possible for a given workflow or a process. That is the only way you can do this. If you do the traditional way, we are not going very far. And that's what most of the people are doing. I've heard since morning, I've heard so many talks. Yesterday, I heard I think, in fact, a speaker who was here on this stage before me, he was saying that we are in infancy stage of AI, right? I don't agree with that statement because, as I think Dan in the first day opening said, AI was there for 50 years. The question is, are we really serious about implementing it the right way? What are we looking at? Right? What is the value proposal? Are we after the models? If you look at the most of the talks are, oh, data quality is not good, data quality is not good. We are not going to change the data quality of the historical data ever. We can only think about the data quality of the future. But if we don't know what is the data quality of the present, how do we change the data quality of the future? So that means you have to start building things on the data that you have, understand it, and then you start saying 6 months from now, we should have this quality data. What people are doing is trying to figure out humanly how to modify the quality. As a data scientist, every time a human being touches the data, it is no longer the truth. If you put a one decimal, if you remove one decimal point, that data is not true. You can tag the data saying, oh, some XYZ person actually modified this data. That is good, but don't delete. A lot of people just go delete the data because they believe that it cannot be possible. The value of, for example, value of temperature from this thermometer cannot be more than 101. And if it say 102, delete the value. You already modified the whole physics. Right? So keep the 102, mark it saying it is not possible for XYZ reason. When you build a model, you can build two models, one with the data, one without the data, without the tag. And so you have two models to compare. What happens when 102 is there and when 101 is 102 is not there? Then you can interpret it as a physics person or as a science or an engineering person. Instead of deleting the data because you don't think it's a good quality data. Now, once you have started thinking of connecting data sets, you can really leverage augmented AI for three things. That is, optimize, automate, and innovate. Here are some of the terms are there which may not be very familiar to all of you. This is all from seismic or geophysics. These are some understanding of physics that is required or the geoscience is required to understand them. What can I do, like, in order to find oil under the subsurface? We have to really automate some tasks, right? Which is called fault interpretation, which means if you think of my hand as a rocks are organized, these could be the faults where the oil could sit, right? So if I can interpret that, then I can say how much volume of oil could be sitting in that, right? In simple terms. Where do I go and actually go drill? Right? If you look at this room, where should I drill? Can we automate that kind of work? Can I actually do various interpretations of things, especially when they are complex? You can optimize those processes using a combination of science and data science. And then the third one is, what can we think of the future? We don't have to really do the same thing over and over again. Can we build some innovative solutions? Once you have learned to optimize and automate, you can think of further building new way of doing things. Right? So, but in doing that, over the last 8-9 years, I can tell you that everything that we do has to relate to value. So, for example, this is just a mining of unstructured data for a particular process. NPT here stands for non-productive time. We are in operational business. If something is not running, that means it's not being producing. Not producing means it's a cost. And by mining unstructured data, something about 16,000 PDF files, completely unstructured, roughly 2% of that new NPT is equal to $200 million. So the second one is that trying to really find where the oil is, increasing that accuracy through combination of AI and science. You can actually increase the accuracy by 80%. For some kind of optimized chemistry that we have to do, we can actually see the returns over the next 5 years. And so when you combine those two things, it becomes easier. But in order to combine those things, you actually need platforms or an ecosystem. And that those ecosystems can be as complex as that. I'm not going to go in details of it. But this is when we build something for an industry, when we want to transform an industry, we build platforms. This is an open earth community platform where a lot of innovation can take place. This is where smaller companies can play on it, and then there are much larger scale industry can actually do things on it. And as a result, we can actually take care of all aspects of science and engineering for this industry, from exploration to sustainability, to the whole process of energy transition. And at the end of the day, if you look at the future of energy transition, you can talk about carbon capture, and you can actually understand how do you take the carbon footprint through the combination of data science models and science. You can actually look at integrated asset managements, and you can see significant value generation. And also in production, you can actually see you see how much data we actually mine. Right, and you can see that how much time we have reduced, how many hours of simulations, and how many functions we can actually do. So, in final, what we can do is start building digital twins of the energy sector. And once we start building those things, all these terms we have heard since last 2 days, so I'm going to skip that. But we can build what we call smart oil field operations or energy operations when you have smart data. And this requires a combination of a lot of things, which is source, operation, consumption, knowledge, and sharing. And you actually, this slide did not come out well, but it's a combination of business models, regulatory affairs, technical aspects, and investment, and that is a source, technology, and consumption. And you will have an energy 4.0 really going for the next generation. Many of these things I have written. Some of those two books are not mine. If anybody is interested, they can download from O'Reilly. They are still available. They're free. They used to be free many years ago. But they talk about some of the challenges in the industry and then a couple of things that I've written. Any questions are there? I would be happy to take if there is time. If not, you can reach out to me on LinkedIn.
We actually don't have time for any questions. Our